Chapter 4, Section 4 discusses ratios and proportions. A ratio is a quotient of two quantities. A quotient you can think of as just a fraction. Quotient really means divide, so you're dividing two quantities and you can use a fraction bar. A proportion is an equation where each side is a ratio, so you're going to end up with a fraction equal to a fraction, and that's a proportion. Okay. Write the following as ratios. So remember, ratio is just a fraction where you're comparing two quantities. Okay. Always reduce when possible. 216 students to 8 faculty. So I'm going to write that as a fraction. 216 over 8. Okay. Then reduce. So we can take 216 over 8. Let me divide by 2 first. So 216 divided by 2 is 108. 8 divided by 2 is 4. And I see that both of these are divisible by 4, so let me go ahead and divide both by 4. 108 divided by 4 is 27. And 4 divided by 4 is 1. Now we are actually going to leave this as 27 over 1 instead of reducing to 27, because remember our answer needs to be a ratio which compares two quantities. So this answer needs to have two quantities. The numerator was students and the denominator was faculty. What it's saying is 27 students compared to 1 faculty member. The next question, 20 hours to 5 days. You want to always use the same label when you can. So we want to either convert hours into days or we want to convert days into hours. Converting hours into days, hours are smaller than a day, so that would make 20 hours become a fraction of a day, which is okay. However, we could go the other way and take 5 days and turn it into hours, and it would just be a larger number. I'm going to go that way and say that 5 days is equal to 5 times 24. There are 24 hours in a day, and 5 times 24 is 120 hours. To make this ratio, we have 20 hours compared to 5 days. So the numerator is going to be 20 hours. And the denominator is going to be the equivalent of our 5 days, which is 120 hours. So notice that the hours and hours match. Okay? And then we can reduce. First, I'm going to reduce them both by 10. 20 divided by 10 is 2, and 120 divided by 10 is 12, and I'm going to reduce again to get 1/6. So it would be 1 hour compared to 6 hours. In the last question, $120 to 75 cents. Notice that the 75 cents, even if you were given it written with the word cents, you would want to convert it so that you're looking at dollars to dollars. So you would have wanted to change that to $120 to, and then changing 75 cents written with the dollar sign. In this case, it was already given to us with the dollar sign, but I just wanted to kind of talk you through what would happen if they didn't. So we can go ahead and make this fraction, $120, and the denominator 75 cents, so $0.75. And then we want to simplify. We don't typically see a decimal within a fraction. I'm going to go ahead and multiply the denominator by 100, and that will move that decimal 2 places to the right, so it's no longer a decimal. And then I need to balance the numerator and also multiply by 100. The numerator is going to be 12000 for the 3 zeros you see. And the denominator, 0.75 times 100, is going to be 75. And then we can keep reducing. Both of these are divisible by 25. I'm going to divide by 25. 12,000 divided by 25 is 480, and 75 divided by 25 is 3. It looks like I can divide a little bit more. Notice that I have not reduced all in one step. You can take as many steps as you need to reduce to this most simplified form. So let me divide both numerator and denominator by 3. 480 divided by 3 is 160, and our denominator is 1. Similar to what we talked about in the first question, when we're working with ratios, we need both a numerator and denominator or comparing two fractions. So in this case, we need to keep that 1 in the denominator also. So you're comparing 160 to 1, or $160 to $1. Question 4 is taking a different way, and it's asking if the proportions are true or false. So the proportions are true if the fractions would be equal to each other. Okay? The left side is a ratio comparing two quantities. The right side is a ratio comparing two quantities. I'm going to show you two methods to check to see if these two ratios are equal to each other. If they are equal to each other, the proportion is true. Okay? The first one I'm going to work on is using a common denominator. So on both the left and the right, I'm going to multiply by both 13 and 65. On the left-hand side, you're going to notice that the 13 divided by 13 becomes 1, and we end up with 65 times 6, and we can get that quantity, 65 times 6, as 390. On the right-hand side, the 65 divided by 65 reduces to 1, and we're left with 30 times 13, which gives us 390. So now we can say that yes, 390 is equal to 390, so yes, this proportion is true. A second method is to use something called cross products. Now, cross products can only be used in very special situations, which is really when you have a proportion, a fraction equal to a fraction. So when we have a fraction equal to a fraction, no other extra terms or adding and subtracting going on, then it will actually give us the same answer if we multiply along the diagonal 6 times 65, and then the other diagonal over the equal sign, 13 times 30. 6 times 65 gave us 390, and 13 times 30 also gave us 390. So yes, this is a true proportion. Notice that cross products is really a shortcut to our method 1. After we reduced the 13 and 13, we were left with 6 times 65, and after we reduced the 65 over 65, we were left with 13 times 30. So really, the method 2 is just a shortcut. Let's go ahead and try number 5. 46 over 17, and we want to know, is that equal to 212 over 95? I'm going to go with that shortcut of cross products because we do have a fraction equal to a fraction. So multiplying along the diagonal over the equal sign, we have 46 times 95. And along the diagonal over the equal sign, we have 17 times 212. On the left-hand side, 46 times 95 would be 4,370. On the right-hand side, 17 times 212 is 3,604. So because these are not equal, no, the proportion is false. Not true. Let's start to solve the proportions. So notice that in question 4 and 5, you were given both numerators and both denominators. Starting with question 6, you're going to have a missing piece, and you need to solve. Again, we could use either method 1 or method 2. I'm going to use that shortcut method where we're using the cross products because we do know that it's equal to using a common denominator. So I'm going to multiply y times 315 and write it as 315y. The other cross product would be 35 times 27. 315y, and on the right we'll simplify and get 945. And getting the y alone, we're going to divide both sides by 315. On the left, we simplify to get y. On the right, we simplify and get 3. So to make this proportion true, and for the two fractions to be equal to each other, our y variable would have to be a 3. Question 7 is similar, only now the variable that we don't know is in the denominator, but we can handle the question in the same way we worked on question 6. We're going to use that shortcut method of the cross products. 2 times s equals 3 times 5. And then simplify and start to solve. On the left, 2s, and on the right, 15. Divide both sides by 2 to get the s variable alone. And 15 divided by 2 is just fine as an answer. If you want to write it as a decimal, it would be 7.5. And either answer would be okay. The last question for section 4.4 is looking at a word problem. Excuse me, I have 2 more questions on section 4.4. So a 450-pound circus tiger eats 15 pounds of meat per day. How many pounds of meat would you expect a 360-pound tiger to eat? I'm going to take each one of the sentences given and make them into a ratio. So the first one in yellow says that a 450-pound tiger, and let me use those labels, 450-pound tiger, eats 15 pounds of meat per day. So in the denominator, the next, what I'm comparing the 450-pound tiger to is the amount it eats, and that's 15 pounds of meat. On the right-hand side of my equal sign is I'm going to use the same idea and make sure that I list the values given in the correct position. And the position is my tiger weight, and in the denominator is the amount that's eaten. So the next sentence given is how many pounds of meat, so food, would you expect a 360-pound tiger to eat? So the 360-pound tiger would follow in the numerator to make sure that it's balanced, similar to our left side. And in the denominator, we don't know how many pounds of meat. Let me use m for meat. And you could use any variable. If you like to use x, you could do that. Now what I'm going to do is I'm going to simplify because we have pounds tiger and pound tiger that are similar to each other. We don't have to rewrite that. And same thing down here, we have pounds of meat compared with pounds of meat. So because we used the same labels, we can kind of simplify this just down to the values. 450 over 15 is the same as equal to 360 over m. And then solve. I'm going to use that cross products as a shortcut. One product is 450 times m. And the second product is 15 times 360. 450m on the left, and then on the right we have 15 times 360. 5,400 when we simplify. Divide both sides by 450 to get the m by itself. And when we divide by 450 on the right, we get a 12. So remember, the 12 is here in the denominator, and it was the pounds of meat that the tiger would eat. Okay. One last question. If $10 of US money can be exchanged for 8.8 euros, then what is the US price of a coat that cost 132 euros? Again, we're going to take each sentence as it comes and make a ratio. So the first one in blue is $10 US. And then what I'm comparing it to, so remember our ratio is comparing two quantities, is 8.8 euros. And the symbol for a euro is kind of a little bit of a curved E. On the other side of my equal, I want to keep that same ratio, but now what we're looking at is we're saying we want to know the US price for 132 euros. So the US price is what we don't know. Let me use an X for the US price. And in the denominator, we know it's 132 euro. So again, because we have US price and euro, we can simplify this down to just the numbers. 10 over 8.8 and X over 132. And we can use our cross products as a shortcut way to solve. One cross product would be 10 times 132, and the other one would be 8.8 times X. 10 times 132 would be 1,320, and on the right-hand side, 8.8x. To get the x alone, we're going to divide both sides by 8.8. On the left-hand side, 1,320 divided by 8.8 gives us 150. And on the right, we get just the x. So the US price would be $150 for the US price. And that ends section 4.4 and chapter 4. Have a good day.